Now this is a little trickier, because this is saying find the coordinates of one of the endpoints, not the midpoint now. And you're given a midpoint, and you're given one of the endpoints. So this is a little trickier, okay? I think this is easier to visualize if we have a little graph. All right, I'm a visual learner, and so I like graphs and any picture that will help me to understand the problem better. And maybe you're like that too, maybe not. One of the endpoints is 1, 1. So I'm going to go over 1, up 1, and that's my dot, okay? That is 1, 1. That's my endpoint. And now I'm given an endpoint at -1, -1. So here's my midpoint right here. Okay, so I've got to have another point that makes this one halfway. So I would have a line down here, and then somewhere out here somewhere, okay, is where it's going to be, so then the distance from there to there is the same as the distance from there to there. That's what we're trying to find. So let's see how this works. We could do this the algebra way. Okay, so midpoint is, remember this, midpoint is, okay, one of the endpoints is 1, 1. So 1 plus the other endpoint, which I don't know, I'm going to call that x, divided by 2. Now, that would be hard if I had a variable here and didn't know what this was, wouldn't it? But I do know the x-coordinate of the midpoint. It's -1. All right, so I can come over here and say, okay, the endpoint is 1, 1, so I got 1 plus, and then the other endpoint I don't know, so I'm going to call it y. Okay, and it's equal to the y value of the midpoint, which is -1. Boy, that's kind of silly, isn't it? It looks exactly the same. Well, to solve this equation for x, I would multiply both sides by 2. Okay, right, and then this cancels out, and I got 1 plus x equals -2, and I subtract 1 from both sides, and I get x equals -3. And of course the other equation in this unique case is exactly the same, so it's also going to be 3, so -3, so y equals -3 over here. And my midpoint, my other endpoint then is going to be at -3, 3. Crazy mouse. Okay, so let's see if that makes sense over here. This one went back 2 units, didn't it? Back 2. This is at -1. Now we're saying the next one's at -3. All right, that's going back 2, isn't it? So 2 units to there, 2 units to there. They're the same. Okay, how far did I go down from that point to this point? I went down 1, 2 units, didn't I? And now I'm going to go down 2 more units. Okay, so, to -3, -3. And so this is at -3. So I went down 2, my scale isn't very good here. Okay, so if I went down 2 and then down 2 more to get to here, okay, then it would be the same. That's just one way of thinking about it. You can do it the algebra way, or you can sort of do it this way, and I'm going to show you an easier way. Then we'll do the next one a little easier, okay? This is kind of cheating. The y's are the same, so we don't have much work to do here. Okay, so we want to know the other endpoint, given that the midpoint is at 4, 2, and one of the endpoints is at 2, 2. All right, so we can draw a picture for this too. This one's going to have, okay, so 1, 2, 3, 4, 2. So this is midpoint. This one is, isn't it? And one of the endpoints is at 2, 2. So it's right here. So what do you think is going to happen to this other endpoint over here? It's going to be on the same dotted line over here, isn't it? Okay, it's going to have a y value 2 also. All right, so, but its distance is 2 units down. Okay, the x values goes from, well, I'll do it from that. Okay, and we're looking for the other endpoint. And remember, this is the middle. Okay, so this is one endpoint, and it's 2 units from the endpoint to the middle, going up 2. So we're going to go up 2 more to get to the other endpoint. Okay, my students really like that method. Always start with an endpoint. So endpoint's 2. We're going up to the middle, which is 4, so it went up 2 units, and then go up 2 more, and you're going to have what? 6, right. Now this one didn't move at all. 0, so add 0 again, you get 2 again, don't you? Okay, so the y value in this one didn't change. But say that it had. Say that it had been a 3 instead of a 2. It went up 1, it would go up 1 more to get to it. All right, and then you can do the algebra way on that, or you can do that sort of mental, let's try this. Okay, the endpoint's 12, the midpoint's -2. So how far did it go, the x value, that's left and right, from 12 to -2? If you need a number line, you know, you can make this a number line, make any number line you want, and have 1, 2, 3, 4, you know, count, and then you got negative, right? And you know, negative numbers are tricky, so drawing a number line is not a bad idea. Okay, so to go from 12, which is way down here, down to -2, it's going to come all the way down to 0, which is 12 units, and 2 more in it. So it's going down 14. If I go down 14 from -2, where am I? I'm at -16. Okay, see what I did from 12 to -2. That's 14 units down. So I'm going to go 14 more units down, and the down is the negative. So it's like I said, okay, -14, okay, and then I add these together and get -16. Now how about this one, 3 to 3? Oh, that one didn't go anywhere, did it? So I'm still going to have a 3 over here. Okay, that would be my endpoint, my other endpoint. Okay, let's try this one. This one looks like both numbers are different. From -2 to 1, how far did I go? Well, here's -2, here's 1. I went up 1, 2, 3 units. And then I'm going to go up 3 more units from that 1. So 1 plus 3 is 4. See, you thought this math was hard. Okay, from 6 to 1. Well, it went 5 units, right? But did it go up or go down? Looks to me like it went down, didn't it? So I was at 6. Okay, I was out here. And I went to 1. So this was 5 units down to here. Now I got to go from here down 5 more units. So if you have a number line drawn on your paper, you can just count it. But it's at -4. Crazy mouse. I think it's because I picked the mouse up off the pad, and that's what makes it do that. It's one of those optical things. It just goes crazy. But it's kind of fun and unpredictable, and that makes life interesting. Okay, endpoint. Okay, let's do it the algebra way for those of you who are thinking, whoa, what is she doing? Okay, 0 plus x, there's my 2 endpoints. Remember, one of them I don't know. Okay, over 2. I think I just run off the mouse pad or something. Over 2, okay, equals -3. And then I'm going to do -4 plus y over 2, is always over 2, and that's equal to the y coordinate of this midpoint, so 1/2. And that, you know, sometimes the algebra thing, if the fractions throw you, sometimes the algebra thing's a little easier. Okay, let's look at this. From 0 to -3 is how many units? 3 units, right? And it's going down, so I'm going to go down 3 more units to -6. Okay, let's see if I get -6. 2 times -3 is -6, and I got 0 plus x equals -6. And of course the 0 doesn't do anything over here, so x is equal to -6. Okay, so either way works. Alright, now from -4 to +1/2. Well, from -4 to 0 is up 4 and then 1/2. So I've got to go up 4 1/2 more from here. because I'm going up 4.5 units. So I add 4.5 to this, and I get the 2 halves make a 1, so I got 5, right? I'm going to go to 5. And see, if I did this, I'd have, what is this? Okay. Oh, I was right. Never mind. I erased it. I forgot what it was. Okay. If I multiply both sides by 2 here to get rid of this, what happens over here? Yeah, I hate to say it cancels out. We kind of get in a bad habit of saying that. But it's really just that it turns into 1. So I get negative 4 plus y equals 1. And then how am I going to get y by itself? I'm going to add 4, and I get 5. Woo! So either way, if you like the algebra way, do it this way. If you like the counting way, do it this way. If the fractions scare you, maybe the algebra is more, with it, because your calculator will do that or whatever. I don't know. Okay? Aha! That was not hard. So let's see if you can do your homework now. Great job, guys.